This is the second part of how I made my orange Tiny Terror copy. If you haven't seen part 1, here is a link to the video. In this video I will go through the process of wiring the electronic components, tube sockets and transformers. So let's jump in. I usually start with the filament wiring. First I mount the tube sockets and I twist a fair bit of wire with a drill. I start daisy chaining pins 4 and 5 of all tube sockets. Please note that I'm using the Russian equivalent 6N2P for the original ECC83 tube. This tube should be similar enough, however the filament wiring is different, so keep that in mind when you're using the ECC83. The thing about filament is that it carries high AC current, which can cause hum. To prevent this, the filament wires are usually twisted, and I found that they cause the least hum if wired to the socket from above. Correct me if I'm wrong, but a common mistake I see is wiring filament like this. So you have the wire twisted neatly, but where the twisting really matters, close to the input pin, you have the wires separated. I mount the AC input and test it if it has a good solid connection to ground. Then I wire up the live wire to the fuse, and I will use the drill again to twist the AC wires together. Now I will mount the power transformer to the chassis, connect the filament wiring to it, and also add a switch between the AC input and the power transformer. This will be my on-off switch. With all that done, I can now test the filament wiring, either using a voltmeter or just checking if the tube starts to glow. Good. Now I move on to putting the panel mounted components onto the chassis, so all the input jacks, spots and switches and all that. I really like these chicken head knobs, but unfortunately the holes are too close to each other and I cannot fit 3 of them there. But actually it's not that bad, since I can highlight the volume and gain with the big knobs and put a smaller one for the tone. This smaller knob has a ugly silver front, so I remove it and now it looks much better. I put in the output transformer as well, so it would be easier to work on the amp when it's upside down. This output transformer is a cheap one from eBay, which has a secondary winding of 8 and 16 ohms. I know it's not the best, but we will see how it works. Maybe I will upgrade it in part 3. By the way, the power transformer is from an old radio. The important thing here is that it has the correct winding ratio for this particular amp. When wiring the tube pins, I found it helps if I bend the pins slightly, being careful not to break any of them. Now I move on to assembling the component board. I don't know what this type of board is called, but I prefer it over the turret board because one lug has 2 terminals. It might seem redundant, but it really helps in connecting the board to the rest of the amp. I mark how many lugs I will need for the board, and then I cut it off with a hacksaw. Now I don't know if this is a British thing, by the way Orange is a British company, but I like the input on my amp to be on the left side instead of the right as it is on the original, so I had to mirror flip the layout. If you are doing something similar, please keep in mind that the pin numbers on the tube sockets will be reversed as well. By the way, layout, you can find the schematics and the layout I use in the description. Based on the layout, I put all the components onto the board. I use 1 watt resistors and mostly film capacitors, but I will have some extra info on the types of components I use in part 3. Here I am making a virtual center tap for the filaments. This is essentially to reduce hum, but more on this topic in part 3. I put the board into the chassis and connect the loose wires from the output transformer so they wouldn't be in the way. I start wiring up the socket starting from the preamp tubes. I try to make a neat job of it, but I think it would make more sense not to have the wires unnecessarily long. So here you can see how convenient these two terminal lugs are. I don't have to hold multiple wires together while I'll solder them. I don't think I took video of it, but just to note, I'm using a solid-state bridge rectifier. The components are now all wired. Let's see if it works. So there's definitely sound coming out of it, as well as a considerable amount of hum. However, since this video is way too long as it is, I will leave that for the next one. See you in part 3.